This is Shankha and welcome to chapter 3 of the Spring tutorial for beginners. So in the first chapter we saw what problems we have with our legacy Java applications, and in the second chapter we saw how Spring can address those problems and provide solutions for them. So in this chapter we're going to see how or rather what modules come packaged with Spring. So this is a very basic diagram showing the modules that come packaged with Spring. So we have Spring AOP, Spring ORM, Spring DAO, Spring Webflow, Spring Context, Spring Web MVC, and Spring Core modules, right? So let's take a look at each of these and see them in details. So first we have the core module. So the core module consists of the bean factory, the application context, and the Spring beans. So it basically provides us a container for holding our objects or holding our beans and for maintaining the life cycle of the objects or of the beans, and for maintaining the relation between various objects that are present inside our application. So the architecture looks something like this. We have the bean factory, which is extended by the application context, and then we have various implementations of bean factory, such as XML bean factory that is shown here, and we have various implementations for the application context, such as file system application, file system XML application context, class path XML application context, annotation config application context, and so on. And then we have the web application context that extends the application context, and then again we have implementations for our web application context. And the core module, the Spring core module, deals with inversion of control and dependency injection. It helps us decouple our components and encourages us to provide our clients with an interface instead of a concrete class. In Spring, the central IOC or inversion of control container is responsible for instantiating application objects. It also configures and assembles the dependencies between these objects. So in our first chapter, we have already seen how creating objects can be a problem or can be challenging for us as application developers, and Spring provides a central container which provides us with the mechanism of inversion of control, and manages the dependencies and manages the life cycle of objects and creates objects for us and maintains relationships between various objects, so we don't have to take care of all those, right? So that is all about the Spring core module, which deals with inversion of control and dependency injection. So next module we have Spring MVC module. And what is Spring MVC module? Spring MVC module helps us build web applications without having to worry about implementing the MVC architecture ourselves. It provides a ready-made front controller design pattern which allows application developers to spend most of their time on business logic and worry less about implementing design patterns and best practices. So MVC stands for Model Controller View Architecture, or it is a design pattern called Model Controller View design pattern. So when we try to build web applications using Java, we need to follow this design pattern, or we need to implement this design pattern ourselves if we are not using a framework such as Spring and we are using just simple Java to build our application. So that is one of the problems that we had for our application, for legacy applications that did not use any framework. So this is the basic architecture for the MVC module that Spring provides. So we have the dispatcher servlet, which acts as a front controller, and all requests that is sent to the application is intercepted by the front controller or the dispatcher servlet, and the dispatcher servlet then goes to the handler mapping, and the handler mapping tells the dispatcher servlet which controller it should go to cater the request and based on the handler mapping output, the dispatcher servlet then goes to a controller which is responsible for sending, or which is responsible for fetching the response from the backend or from some place. Basically, it is responsible for providing the response back to the dispatcher servlet, and the response might be tied to or might be associated with a view. So the dispatcher servlet goes to the view resolver to see if it is associated with any view or not, and if it is associated with a view, it goes to the view and renders the view and returns the HTTP response. Now oftentimes we would not be dealing with views, we would not be dealing with a user interface, we might be exposing our application as an API. So in that case, we won't be having a view resolver resolve a view. We'd rather be sending a response, maybe a JSON response or an XML response or such as a stuff. So that is basically how the Spring MVC architecture or MVC design pattern looks, and this is the basic architecture diagram for the Spring MVC module. Okay, so next up we have the Spring Webflow module. And what is it? The Spring Webflow module is an extension of the Spring Web MVC module. The Spring Webflow helps in defining XML file or Java class that manages the workflow between different pages of a web application. The following are the advantages of Spring Webflow. Number one, the flow between different UIs of the application is clearly provided by defining Webflow in XML file. Webflow definitions help us to virtually split an application in different modules and reuse these modules in multiple situations. Spring Webflow lifecycle can be managed automatically. So Spring Webflow is basically an extension of the Spring MVC module, and it helps in defining XML files or Java classes that manage the workflow between different pages of a web application, and how they are interconnected is basically defined through a Spring Webflow module, right? And next up we have the Spring Data module. So in our first chapter or in chapter 1, we have already seen how connecting to database can be a headache or can be a challenge for an application developer, and writing boilerplate code or writing JDBC boilerplate code every time is just not something that we would want to do and want to spend much time on as application developers. So what is Spring Data module? Spring Data module provides an abstraction over Java to database connectivity and introduces a JDBC abstraction layer by eliminating the need for providing tedious JDBC coding. It also provides implementation for abstract query methods declared inside data repositories, thereby reducing boilerplate code. It supports heterogeneous Java database connectivity and object relational mapping, which helps Spring work with several data access technologies. So we can have different kinds of databases. We can have relational databases, we can have non-relational databases such as MongoDB and other stuff as our backend. And Spring Data provides a wide range of interfaces to provide an implementation for connecting to such kind of databases, and we need not worry about writing the connectivity code every time we have to connect to a backend or we have to connect to a database, right? So that is all about Spring Data module, and this is a very basic architecture diagram for the Spring Data module. So we have the repository, and then we have the CRUD repository and paging and sorting repository, and then we have the Spring Data JPA layer, and then we might have multiple database backends. So this is an RTBMS or relational database, and then we have MongoDB, which is a non-SQL or a non-relational database. We have Neo4j, we might have other types of databases. So Spring has connectivity implementations for all these kind of databases, and we need not worry about writing code for connectivity, JDBC code for connecting to different kinds of databases, right? And this is the basic hierarchy for Spring Data JPA. We have the repository, which is inherited by CRUD repository, and then again this is inherited by paging and sorting repository, and this is inherited by JPA repository, right? So next up we have the Spring Application Context module. So the Spring Application Context module is based on the core module. So already we have seen in the core module that the basic functionalities of the core module are inversion of control and dependency injection, right? And application context is an interface of Bean Factory. This module supports functionalities such as internationalization, validation, event propagation, and resource loading. The application context implements message source interface and provides the messaging functionality to an application context. So the application context is basically a container which contains the beans, Spring beans that are managed by Spring, that are created by Spring, and Spring is also responsible for maintaining the interdependency between these Spring beans. So we need not worry about how these beans are connected to each other or how objects of these classes or these beans are created. We leave it up to Spring to create objects for us and maintain them inside the application context, right? So next up we have Spring AOP module, and AOP breaks down the program into aspects or concerns. Spring AOP module allows you to implement concerns or aspects in a Spring application. In Spring AOP, the aspects are the regular Spring beans or regular classes annotated with @aspect annotation. These aspects help in transaction management and logging and failure monitoring of an application. It helps decouple the cross-cutting concerns from the business code. So as discussed in chapter 1, separating or decoupling the cross-cutting concerns from the business code is a big challenge in our legacy applications. So Spring AOP comes into our rescue by providing a mechanism to decouple the cross-cutting concerns from the business code. And we have different kinds of advices that we can use for intercepting our methods and intercepting our aspects. And here we can see we have the various types of advices that we can use: before advice, after advice, method before advice, after returning advice, throws advice, and such other stuff, right? So next up we have the Spring ORM module, and Spring ORM module works in conjunction with Spring Data. The Spring ORM module, which is the Spring ORM module, is used for accessing data from databases in an application. It provides APIs for manipulating databases with JDO, Hibernate, and iRetis. It provides simple declarative transaction management, transparent exception handling, thread safe, lightweight template classes, DAO support classes, and resource management. So again, object relational mapping is a big issue with our legacy applications, and the Spring ORM module really makes our lives as application developers much easier with its solution for ORM management, object relation management. So those are some of the modules that we have in Spring, and in our later chapters we'll see how each of these modules work. And until this chapter we have only seen theory, or we have only talked about theory, but from the next chapter onwards we're gonna see some code, and we're gonna see how the Spring Core module works and what the Spring Core module is all about. So that is all for this chapter, and I hope you guys enjoyed this video, and if you did enjoy, please give it a thumbs up and stay tuned for chapter 4. Thanks for watching.